All right, guys, this is section 6.2 on rearranging formulas. You've already had to do this a bunch in this course, just in the geometry and in the trigonometry unit. So I think this will be quite easy for you. Some problems for you to solve today, tomorrow, and the next day, and then that's it. All right. Just looking ahead, you're probably looking at a test in a couple of weeks' time. Not next week, but the week after. I thought Chapter 6 would take us about 3 weeks. So you'll be looking at a test or a chapter assessment assignment. Not next week, but perhaps the week after. We'll see how it goes. So I'm going to start with just showing you how to isolate some variables. So in the formula, A equals P plus I, if I want to isolate P, what you have to do is subtract I from both sides. There's no sense in putting P over on the left if that's what I want to isolate for, and then positive I minus I cancels out, and I'm left with A minus I on the left equals P on the right. Now, if that freaks you out, if you're not comfortable writing it like that, you could just flip the entire thing and say, okay, well, if A minus I equals P, then I can write P equals A minus I. And that's just fine, right? You can have it like that. You can have it like that. In the classic volume of a rectangular prism, volume equals length times width times height, or LWH. Let's just try and solve for H just because. So in the first one, we had to use addition, subtraction to get rid of the I. But in this one, it's multiplication. So to get rid of it, we need division. So if I want to solve for H, I have to divide out the LW, divide out the LW. So I'm left with V over LW equals, and it cancels, equals H. Again, you can leave it like that. That is the right answer. But if you don't like that, you could write it as H equals V over LW. In our last formula, I equals V over R. If I want to solve for V, well, then I got to get rid of this R on the bottom. So what you do is you multiply both sides by R. R divided by R cancels out, and I'm left with I times R on the left equals V. Again, if you don't like that, you could write it as V equals I times R. Both of these would be correct. So now you've got 1, 2, 3 examples. One of them involved addition, subtraction. One of them we had to divide to get rid of the L and the W. And then the last one we had to multiply by R to get rid of the R. And those are some of the skills you're going to need here. So the rest of the examples are essentially problem solving. So the question is, convert 20 degrees Celsius to Fahrenheit. This is the Fahrenheit to Celsius formula here. So we have to take it the other way. So I hope I have enough space to do this and show you two methods. So the first method that I'm going to do here on the left is going to be where we isolate F first. All right. So first thing we got to do, this is divided by 9, by the way. I just had trouble getting that character into here. So it's 5 F minus 32 over 9. So to get rid of the 9, let's focus on it first. You got to multiply both sides by 9. All right, so now you've got C times 9 equals 5 F minus 32. I don't expect you to show every one of these steps when you're doing these, but I'm going to show you every step because I don't know exactly where you guys are at with this stuff. Step 2, get rid of the 5. It's multiplied by 5, so divide both sides by 5. That gets rid of the 5. Now you have C times 9 over 5 equals F minus 32. I think that's all we got left. C times 9 divided by 5. To get rid of negative 32 on the right, we're going to add 32 to both sides. I'm going to add 32 to both sides. So I'm going to have C times 9 divided by 5 plus 32 equals F. Just remember your order of operations. You got to go the Celsius times 9 divided by 5 first. The last thing you do is add the 32. So I'm going to substitute that in right now. I don't have space to show it, but I'm going to put in my 20 degrees. 20 times 9 divided by 5. I'm going to hit equals. That makes 36 plus 32 is 68. So the Fahrenheit value is 68 degrees. On the right, I'm going to show you the other way, and you can get the answer just as well doing this. And that would be substituting the 20 degrees in first. So I'm taking that formula from the top. 20 degrees Celsius equals 5 times F minus 32 divided by 9. So I'm going to use the same approach. I'm going to multiply the 9 up with the 20. So I'm going to go 20 times 9 is equal to 180. So instead of keeping that C the whole time, when you're using this method, you got a number over there on the left the whole time. Next thing, divide by the 5, just like we did before. 180 divided by 5 is 36 equals F minus 32. And then finally, you bring over the 32 and add it. And of course, you get the same answer, that your Fahrenheit value is 68 degrees. So I don't care which method you use. The first method is a little bit more mathy if you're into that. A good math teacher would probably like to see you do that, but I really just want you to solve these problems and get the right answers, okay? And this is probably the only one where I'll show you both ways of doing it. I'll just kind of pick one or the other when I go through the rest of these problems. So area of a circle, A equals pi r squared. Determine the radius of the circle. We want the area to work out to 10 square meters. All right. So in this one, I don't know, just for no particular reason, I'm going to choose to rearrange the formula first. That was the first method that I used. So I'm trying to get r by itself. So the first thing I got to do is divide both sides by pi. That gets rid of the pi. So what do I have left? Just r squared, and it's a over pi. I got one more step to do, and that's with the square. I got to do something with that. And the way that you do that is you square root both sides, because the square root of something squared is just going to be r. And then, of course, over here, I've got the square root of a over pi. And now I substitute in my values. So it's going to be the square root of what? 10 square meters over pi. So all I have to do is type in 10 divided by pi. I'm using my pi button. And then I'm hitting square root. And I got one decimal. I'm going to round my answer to 2 digits, 8. And that is meters. You'll get the same meters squared. It'll be meters for the radius. That's what I got. At any point, you guys should be pausing this video and checking my calculations. I'm not saying I'm going to get through this whole semester without making a mistake. I'm sure I will. I don't have the answers sitting here in front of me, so off we go to the next one. Here's the volume of a sphere formula, 4/3 pi r cubed. It says determine the radius of a ball if we want the volume to be 2 cubic meters. So again, for no apparent reason, I'm going to choose to substitute that 2 meters cubed in first, just to show you the other way. So that's 2 meters cubed equals 4/3 pi r cubed. So the 4/3 is actually a decimal, right? It's like 1.3 repeat or something like that. So you can use it like that if you want. You could work out what this all is right here if you want to at first. Why don't I do that? So I go 4/3 times pi, which is 4.189. So it's 4.189 r cubed, and over here I've got a 2. So to get rid of that 4.189, I got to divide both sides by 4.189 divided by 4.189. right? That gets rid of the 4.189 here. And on the left side, I've got that times 2, and it equals 0.477 equals now r cubed. So what we want to do here to get rid of a cubed is you take a cubed root. You'll have to find that button on your calculator, but we need to take a cubed root. That gets rid of the cubed, and I'll be left with just r by itself. On my calculator, it's the second function or shift square root button. Anyway, when you found it and used it properly, I hope, it equals 0.78 meters for the radius. All right. And that's the way I chose to do that one. That's not the only way, especially that first step I took where I put the 4, the 3, and the pi all together to make the 4.189. You could have went a different route there. You could have got rid of the 4/3 by itself first and then got rid of the pi. That would be just fine. The questions I want you to do are on these 2 pages, 354, 355. And I don't think I can zoom in on this. No, I can't pitch to zoom on this. There are the questions. If you want to pause it here and just look off of here, that's just fine. I can't remember exactly the ones that I chose, but you see how a lot of the first few have an A, a B, an A, a B, an A, B, C. I just wanted you to do one of each of those. So I think I said do just very specific questions here. And then where I really wanted you to do more was in 9 through 12 on the right side there on 355. Well, here it's on the next slide, so just to look at it. So starting on 5, 5A, 6A, 7A, 8C, and then 9 through 12. So starting on number 5. And each of them is a problem with a formula, where you're going to have to rearrange that formula to solve it. The name of the game here, the whole point, the theme of this section is solving equations. And that means rearranging those equations to solve. All right. So that's section 6.2. If you guys have any problems with any of the questions, just email me. I haven't gotten an email I don't think all last week you guys have any questions for me. So if you get stuck on anything, just ask. Even on the chapter assessments, they're not a test. I'm using them as your test mark, but they're really not a test. If there's anything you're stuck on, just ask and I'll help you through it. The point of them is for you to understand them and get perfect on them if possible. So that's all for today, folks. Actually, that's all for this week. Just get the stuff done from Monday, get this stuff done, turn in your work, and then relax. I think the weekend's supposed to be nice, so hopefully you're done all this math stuff by then and you can just relax and enjoy some warm-ish weather for a change. All right, guys, good luck.